Students will be able to write and solve equations involving direct variation. The first question that I'm going to work out for you is question number 4. The directions for question number 4 ask you to sketch the graph and then determine if the graph represents direct variation. If it does, state the constant of variation K. Before we start this question, let's first talk about what direct variation is. Direct variation is a mathematical relationship between two variables where an output is equivalent to an input times a constant. To represent this algebraically, we would use this equation y equals kx, where k is the constant of variation. Think of the constant of variation as like the rate of change. How is it changing? How is it increasing or decreasing? When you look at the graph, you want to be sure that it is passing through the origin of the coordinate plane, the center of the coordinate plane, 0, 0. For a graph to be a representation of direct variation, it must pass through that center. It must pass through 0, 0. Now let's go back to question number 4, and let's determine if this equation y equals 1/2 x represents direct variation. The first thing I'm going to do is I'm going to graph it. From my homepage, I want to go to graph, press tab to bring it up. Remember that y equals and f of x equals are similar, so we don't have to change that to y, but I do need a fraction, 1/2, and then my x. When we look at this graph, we see that it does in fact pass through the origin, so this does represent direct variation. The line is increasing, which means it has a positive slope. Now we know this, let's go back and sketch what this graph is supposed to look like. There's the center, the origin, and it's going to look like this. So does this represent direct variation? Yes, because it passes through 0, 0. So now we have to find the constant of variation K, which remember I said that's kind of like rate of change, and we know rate of change is slope. Recall the equation of a line, y equals mx plus b. When it is written in this form, m is your slope or your rate of change. So we're looking for the number in front of the x that is going to be our constant of variation. Look back at the formula for direct variation. The k is in front of the x. So in number 4, y equals 1/2 x, my constant of variation should be 1/2. If the equation is not written in this form, that's okay. You can find 2 points and find the slope or the rate of change that way. Or you could do rise over run. We're rising 1, we're running 2, we're rising 1, we're running 2. Okay, so either way, any of those 3 methods, as long as you're finding your slope, your rate of change, that's going to be your constant of variation K. The next example that I'm going to be working out for you is question number 7. The directions for question number 7 ask you to write a direct variation equation that represents the two variables, then solve. Number 7 says, suppose y varies directly as x and y equals 16 when x equals 8. Find y when x equals 16. So here we are relating two things. We're relating x and y. So to come up with an equation, we're going to form a ratio. In the ratio, I'm going to put x on top and y on the bottom. And I'm going to need another identical ratio, x on top, y on the bottom. To make this into an equation, all I have to do is put an equal sign in the middle. So we have x over y equal to x over y. If you had flipped it and done y over x, then your other side must match it. So it would have been y over x equals y over x. It doesn't matter as long as you keep it consistent. I'm going to read the problem again. I'm going to highlight the given information. Suppose y varies directly as x and y equals 16 when x equals 8. Find y when x equals 16. So let's just substitute these numbers in. In the first ratio, y is going to equal 16. So I'm going to put 16 in my denominator because that's where my y is. So the 16 goes here on the bottom, not here. 16. When x equals 8. So when ties them together. So 8 is going to go on top. So we have 8 over 16. Y equals 16 when x equals 8. X is on top, x is 8. Y is 16, y goes on the bottom. 8 over 16 is my first ratio. Then the problem says to find y, we know we're going to be solving for y when x equals 16. They give me x is equal to 16. Again, my x is in the numerator. It's on top, so I'm going to put the 16 here, not here in the denominator. So 16 on top, y in the bottom. The reason I'm putting y in the bottom is because my y is unknown. I need a variable to represent it. The next step to this problem is going to be to cross multiply. 8 times y, 16 times 16. 8 times y is 8y, and 16 times 16 is 256. Now I have an equation, 8y equals 256. To get y by itself, I have to divide that by 8, which means I'm going to divide the other side by 8 as well. Here the 8's cancel out and leave 1y, and that is equal to 256 divided by 8, which is 32. So y is equal to 32. Find y, we just did 32. And the last example I'm going to be working out for you is going to be number 11, same directions. Let me read it for you. Maria is baking muffins. The recipe calls for 2 pounds of flour to make 6 dozen muffins. She decides she only wants 3/4 of a dozen. How much flour must she have? In this question, we're relating flour to muffins. When I set up my ratio, I'm going to put flour on top, muffins, or the quantity of muffins on the bottom, equal to, again, keep it consistent, same thing on the other side, flour over muffins. Let's highlight the important information. The recipe called for 2 pounds of flour for 6 dozen muffins. She decides she only wants 3/4 of a dozen. How much flour? Okay, so flour, 2 pounds. That goes in my numerator. 2 over 6 dozen muffins equal to, again, flour. How much flour? We don't know. The question asks how much flour. So I'm going to just put F. F represents flour. You could use any variable, X, Y. In the denominator, I need muffins. We're going to go with 3/4 of a dozen. Now I'm going to cross multiply 6 times F. That gives me 6F. And 2 times 3 over 4 gives me 1.5. I'm going to put it into decimal form because it's easier for me to multiply and divide a decimal than a fraction. Now I have to divide both sides by 6 to get the F by itself. F equals 0.25. Now I can convert that back to a fraction, and that's a very common one. It's 1/4. So Maria needs 1/4 pound of flour to make this recipe. That's my final answer. Thanks for watching this video. For more videos like this, please hit the subscribe button. Also, Follow us on social media or visit us at almightyalgebra.com.